Welcome back to Statistics. I want to talk today about a basic distinction that between descriptive statistics and inferential statistics. So, what's the difference? Well, descriptive statistics is just what it sounds like. It's statistics that are designed to describe or summarize or visualize a data set. And so, for instance, if I say that I have surveyed 100 Hamden Sydney students and found that 48 of them prefer Donald Trump for the November election, that 48 would be a descriptive statistic. If I converted it to a percent and said 48% of my sample preferred Trump, that would also be a descriptive statistic. Anything I can say based on the sample alone would be a descriptive statistic. So, what's an inferential statistic? Inferential statistics refer to estimates or claims about a larger group that are based on data that you have from a smaller group. So, for instance, if I said something like this, based on my survey, I'm going to estimate that somewhere between 45 and 51% of all Hampden Sydney students would prefer Trump in the November election. I would be making an inferential claim. It would be an inferential statistic. Excuse me. And so the essence of inferential statistics is that move from data about a smaller group, often a sample, from a population, to a claim about a larger group, the population the sample came from. That is what distinguishes inferential statistics. So let's take a little closer look at this. I'm going to open up some slides that I have prepared for this purpose. And here's a graph that, or a figure that just basically illustrates this distinction. Descriptive statistics are designed to understand, visualize, and summarize a data set, while in inferential statistics, we use sample data to make estimates and draw conclusions about a larger population. So here's an example that I'd like to dive into a little bit more deeply to discuss this distinction. And the example also introduces a plot of a certain type that we'll be seeing a lot over the course of the semester. This is called a back-to-back stem plot. And in this case, we're using it to compare graduation rates of basketball players at a certain set of schools to the rates for all athletes at those schools. The schools that we're talking about here were NCAA Division I schools that sent their teams to the playoffs. So it's not all NCAA Division I schools that we have in our data set, just the ones that sent their teams to the playoffs. And I believe the year was 2009. And so the data, it describes those schools. So for instance, looking at graduation rates for basketball players, we have the data presented in this stem plot is kind of a little strange the first time you see it, but this first school had a graduation rate of 8%. So the way you read that is the digits in this middle column here are called the stems. They're the tens place of the graduation rate. So 0 would refer to 0% up to 9%. 1 would refer to 10% up to 19%. 2 would refer to 20% up to 29%, and so on, the tens place of the percentage. And then the leaves, each leaf is the ones place in a school's graduation rate. So this first data point is 0.8 or 8%. The second data point is 10 or 10%. The third data point is 17 or 17%, and so on. 20%, 29%, 30, 31, and so on. So we see that the graduation rates for basketball players at these schools ranged from 8% all the way up to 100%. There were actually 1, 2, 3, 4, 5, 6, 7 schools who graduated 100% of their basketball players in our data set. So good for those schools. If you look at the graduation rates for all athletes, or for other athletes, not the basketball players, you see something quite different. The minimum graduation rate there was 48%. And then you have 53, 56. Two schools had graduation rates of 57%, and so on. So the graduation rates for other athletes ranged from 48% up to 94%. And so, quite a different situation for other athletes as compared to basketball players. So, that's a back to back stem plot, and it's useful for comparing uh, the data between these two groups, basketball players and all athletes. Now, anything we say based just on this data, since this is our sample data, would be a descriptive statistic. We have 63 schools that sent basketball teams to the playoffs. We have 56 schools that sent athletes of other kinds to the playoffs. So that's our data set. You could pull out a lot of interesting information from this data set. For instance, you could ask, what's the median graduation rate for basketball players at these schools? And so the median we'll get into a little later, but it's basically the 50% point, sort of the middle of the data set. And just finding the middle of the data set, the graduation rates for basketball players, it turns out to be 50%. And so the median graduation rate for basketball players here is that 50%. And in the same way, we can find the median rate for other athletes at these schools. And that turns out to be 78%. So right there, you see a difference between the graduation rates for basketball players at these schools versus other athletes. These medians, 50% and 78%, would be descriptive statistics because they describe the data that we have in front of us. There are a host of other descriptive statistics you could pull out of this, and we'll be doing a lot of this going forward. But for instance, you could look at which schools graduated 50% or more of their athletes. If you look at the basketball players here, I've highlighted those schools here in red. Turns out that there's 40 out of the 63 schools, or 63.49%, have graduation rates of 50% or better for the basketball players. And in the same way, we find that 55 out of the 56 schools that sent other athletes, other kinds of athletes, to the playoffs had graduation rates of 50% or better. So a much higher percentage had graduate of other athletes, non-basketball players. Much higher percentage of schools graduated 50% or more of those. Those again are still descriptive statistics because they were describing the data set we have in front of us. So, what kind of inferential statistical move could we make here? Well, remember our data set is for schools that sent players to the playoffs, but there's a lot of other NCAA Division I schools as well. And so, for instance, I could looking at our data, I might make a hypothesis that graduation rates for basketball players at all NCAA Division I schools are lower on average than graduation rates for other athletes. That would be an inferential statistic because we're using the data we have about the schools that sent players to the playoffs to make a hypothesis or a claim about all NCAA Division I schools. And so that would be another example of an inferential statistic. And that kind of distinction, again, is going to be essential to us moving forward. So I hope this has helped you clarify that distinction. It is an important part of what we're about in this course. And so we have a homework set that is focused on this distinction, and I hope it helps you work your way through that as well. We'll be back at you real soon. In the meantime, if you have questions, just let me know. Y'all take care.